Session 8.3 Hypothesis Test in Details. For these sessions, we're going to talk about the possible source of error in hypothesis testing. And then we're going to learn what is a practical significance, what is a statistical significance. And remember, we learned the confidence interval from the chapter 7. And we want to identify the similarities and the difference between hypothesis testing and the confidence interval. We're visiting small p-values. A small p-values means our test statistics is extreme. An extreme test statistics means something unusual, and therefore unexpected has happened. Small p-values lead us to reject the null hypothesis. Let me explain these three guys here. Okay, let's say we have the normal distribution here. A small p-value means our test statistic is extreme. So, first, let's say my test statistic is going to be somewhere like here. Okay, we assume we are working on the left tail test. And then we're going to use the test statistic to find the area of the left tail, this part here. And we call this is going to be your p-value. A small p-value means our test statistic is extreme. So you could think about it. P-value is going to be the area of the left tail. If my p-value is really small, somewhere like here. Okay, if this is going to be my p-value, that means my test statistic is somewhere like here. When I compare with these two pictures, if I have a small p-value, that means my test statistic is also very small. Okay, this is what they say, test statistic is extreme. And extreme test statistic means something unusual. So remember on the picture on the chapter 2, we find it like unusual. Usual and unusual. This is gonna be the maximum usual. And this one is gonna be the minimum usual. Okay, or you could think about like this is gonna be the mean plus 2 standard deviation. This is the mean minus 2 standard deviation. Anything less than the minimum usual, this is called unusual, right? Or anything greater than the maximum usual, this is also called unusual. Extreme test statistic, that means the z here will be less than the minimum usual or will be greater than the maximum usual. Okay? And the small p-values lead us to reject the null hypothesis. And remember that we could consider this is the null hypothesis, and here this is gonna be your alternate hypothesis. Okay, and then we're gonna use the p-value compare with your significance level to see you're gonna reject or fail to reject. If you do have a small p-values somewhere like here, for sure this p-value will be less than or equal to your significance level. So in this case, we're going to reject the null hypothesis. Okay, so you can think about it like small p-value, we do have a higher chance to reject the null hypothesis. If conditions fail, if the conditions concerning the sampling distribution of the z statistic fail to be met, then we cannot find the p-value using the normal curve. Condition can fail for the following reasons. Remember for the session 8.2, we do have 4 conditions. We have to meet the 4 conditions in order to use the normal curve, and then we're going to use the test statistic, and then we're going to find the p-value. But if the condition fail to be met, then we cannot use the normal curve to find the p-value. And the conditions are going to be like this. Sample size is too small. Samples are not randomly selected. In this case, conclusion may not generalize to the populations. So if we fail these conditions, then we cannot use the normal curve to find the p-value. Potential mistakes in hypothesis testing. There are two types of potential mistakes that can occur in hypothesis testing. When we perform the hypothesis testings, we may make a good decision or we can make the mistake. For example, if the null hypothesis is true, this is true. We fail to reject it, so we make the good decision. Or when the null hypothesis is false, we reject it. We believe this is wrong, so we reject this guy, so we make the good decision, right? But sometimes we may make a mistake. When the null hypothesis is true, we reject it. Okay, this is true, but we reject it. We believe the alternate hypothesis is true. So we make a mistake. The probability of doing this is called the significance level. So maybe something happens on your significance level, or sometimes the null hypothesis is false, but we fail to reject this guy. We believe this is true. So we make a mistake in here. Look at this example. Suppose a political analyst is interested in predicting whether a school bond measure on the ballot will pass. Her hypotheses are the null hypothesis, population proportion equal to 0.50. Alternate hypothesis, population proportion will be strictly greater than 0.50. Describe two types of errors you may make in conducting this test. Explain what a 5% significance level means in the context of this example. So we have this table here, okay? When the null hypothesis is true, we're gonna reject it, so we make the mistake. Or the null hypothesis is false, but we fail to reject it, okay? So first, rejecting the null hypothesis when it is true. This guy may be true, but we reject it. We believe the alternate hypothesis is true. This means conducting that more than 50% favor the bond when the actual proportion who favor the bond is 50% or less. Second one, we're failing to reject the null hypothesis when it is false. This guy is supposed to be false, but we fail to reject, so means we believe this is true. This means conducting that 50% or less favor the bond when the actual proportion who favor the bond is more than 50%. This guy should be true, right? Alternate hypothesis should be true. So we should say the actual proportion who favor the bond is more than 50%. And then now we're going to talk about the 5% significance level. The 5% significance level means there is only a 5% chance that the analysis mistakenly concludes that more than 50% favor the bond when, in fact, they don't. The statistical significance. When we get a result that is very unlikely occur by chance. So again, highlight this one, unlikely to occur by chance. If the event is unlikely to occur by chance, we call this as a statistical significance. For example, getting 55 blue cars in a 60 cars. Think about it, is this event, is it unlikely to occur? Yes, right? 60 cars and I have 55 blue cars in it. So this is unlikely to occur by chance. So we say the event is statistical significance because this is really extreme result. Okay, example number 2. Getting 10 girls in 45 students. So think about it, if we have a class here, we have a 45 students, is it easy to get 10 girls? Yes, right? This is unlikely to occur by chance. So this is not statistical significance because the event could easily occur with random chance. Okay? Memorize definition of statistical significance. Very unlikely to occur by chance. And most likely, we could say like 5%. Everything less than 5%, we call this is unlikely to occur. Okay, second one, practical significance. It is possible that some treatment or finding is effective, but common sense may suggest that the treatment or finding does not make enough of a difference to justify its use or to be practical. This is the requirement for the number one. The treatment or finding is effective, okay? It has to be effective. This is the first requirement. And then you're going to think about it. Common sense may suggest that the treatment or finding does not make enough of difference to justify or use or to be practical. Okay, let me use the example here to explain what is the meaning of practical significance. Okay, for example, there's a guy come to me, say, hey, you want to improve your fuel efficiency of your car? And I say, of course, why not? I want to save more money. And then he introduced the X ingredient. He say, if you put the X ingredient into your car, it's gonna improve the fuel efficiency. And I don't really trust this guy. So what I gonna do? I gonna set up my experiment. Okay, let's say this is gonna be my car. Okay, so I'm gonna do my experiment. I'm gonna drive a road in the morning at 6 a.m. and I'm gonna drive like 400 miles. And I find out I only need 14 gallons of the gas. Okay, 14 gallons. And then I'm gonna ask this guy, hey, can you give me the X ingredient? I will just try a little bit to see if it could improve the fuel efficiency. And then the guy say, oh, okay, just try it. And then he give me the X ingredient. So what I gonna do? Okay, this is gonna be the X ingredient. And then I'm gonna put it to my car. And then after I put the X ingredient to my car, I drive to the same road with the 400 miles. Okay, the same time, same road, same car. And I find out I only need to use 5 gallons of gas. And I say, wow, it really works, right? The same car, same road, the same mileage. I only use 5 gallons of gas instead of 14 gallons. So means the X ingredient, this is really effective, okay? This is really good. And I say, and I go back to the guy, hey, this is really cool though. How much is it? And then the guy tell me, this X ingredient costs you $1,000. And it only good for a week. Means every week I need to buy the X ingredient. It costs me $1,000. So think about it. Do you guys want to use it? You guys want to buy this X ingredient? No, right? Because $1,000. I only save like about 9 gallons of gas for 400 miles. And this X ingredient spent me like $1,000 and only for a week. So in this result, we call this is not practical significance. Okay, not practical significance. Okay, because one more time, the finding is effective. It fulfills the first requirement. Okay, finding is effective, but the second one, this is not practical because that's too much of $1,000. And then a month later, okay, 1 month later, the guys come to me and say, hey, we are on the special. It's only $20 for the X ingredient and it's good for a week again. So what do you guys think? Of course, you want to buy it because I do the experiment already. It saved me 9 gallons of gas for 400 miles. And right now, it's only like $20. Again, the finding is effective. It's fulfilled the first requirement. And also, it is practical, right? So if the X ingredients selling like $20 right now, then we could say the conclusion. This is practical significance. Okay, practical significance. Okay, one more time. If they sell $1,000, it's not practical. Then $20, this is practical. Okay, practical significance. So you guys learned two conclusions in here. First one,
statistical significance, okay, unlikely to occur by chance. Second one, practical significance. Make sure the treatment or finding is effective first, and then you're gonna prove it's gonna be practical or not practical. Okay, I want you guys to try on this example. Okay, think about it. If this weight loss program have a statistical significance or have the practical significance. Okay, in a study of weight loss program, 35 subjects lost a mean of 2.7 pounds after 12 months. Method of statistics can be used to show that if this diet has no effect, the likelihood of getting this result is roughly 10 chance in 1,000. Okay, so means you want to join this weight loss program. You do lose 2.7 pounds after a year. And then the last sentence here, highlight this one, is roughly 10 chance in 1,000. That means if I didn't join this program and I want to lose like 2.7 pounds, it's gonna be 10 chance in 1,000, so it's gonna be 10 over 1,000, which is gonna be 0.01 and 1%, right? So meaning that this is gonna be less than 5%. So think about it. Does the weight loss program have a statistical significance? Remember this definition? This is very unlikely to occur by chance. And 1%, this means very unlikely occur by chance. So we say yes, because the result unlikely occur by chance. How about the second one? Is there practical significance? Think about it. If I want to join this weight loss program, let's say I'm 200 pounds, okay? I'm 200 pounds. And I need to spend a year. 1 year, I only lost like 2.7 pounds. Like, I need to spend like 10 years. I only lost like 27 pounds. All right? So does it practical? No, right? The treatment is effective. Okay, the treatment is effective because this is 1% only. But it's not practical.
Reducing mistakes. How can we reducing the mistakes? The only way to reduce the probability of both types of mistake is to increase the sample size. Increasing the sample size improves the precision of the test, so we make the mistake less often. Okay, so one of the conditions we have to remember that we want a large sample size. We cannot make the significance level too small because this increases the probability that we mistakenly fail to reject the null hypothesis. We can't make it like too small. Usually we make it like 5%. Okay, the significance level usually equal to 0.05. Caution about writing conclusion, because we can never be 100% certain that our conclusion in hypothesis testing is true. When your p-value is greater than your significance level, avoid using any of the following phrase. We accept no hypothesis. You know, when I explain to you guys, I may say that, but when we're working on the hypothesis testing, we never say we accept it. We only can say we have failed to reject. Okay, fail to reject means we may not have a sufficient evidence to reject this guy. But we never say we're gonna accept the null hypothesis. Or you never say we have proof H0 is true. Okay, we can't say that. We only can say we cannot reject the null hypothesis. Okay, so when you drawing the conclusion, we'll be using this sentence rather than we say accept it or we prove it. Confidence interval and hypothesis testing. Remember, we learned how to construct confidence interval in the chapter 7, and then we learned how to perform the hypothesis testing in the chapter 8. And actually, these two guys are close related. Okay, it's really similar to each other. I could answer the question using the confidence interval or the hypothesis testing. Confidence interval, what is the value of this parameter? So we are working on the population proportion that will be within like this range. Or you could say the population proportion will be within 41% to 58%. And the hypothesis testing, are the data consistent with the parameter being one particular value, or may the parameter be something else? So we're gonna set it up either the null hypothesis is gonna be equal to 30%, or your population proportion is gonna be strictly greater than 30%. So my null hypothesis saying that population proportion will be equal to 30%. Alternate hypothesis saying that the population proportion will be strictly greater than 30%. Actually, these two guys, I could answer the same questions though. Like for example, I know that the population proportions that is in between 41% to 58%. And if I find out this confidence interval, I would believe that the alternate hypothesis is going to be true. Because this is talking about the population proportion is going to be strictly greater than 30%, right? Greater than 30%, that will be in between here also. So like if this is the same question, same data here, I will reject the null hypothesis and I believe the alternate hypothesis is true. Because population proportion greater than 30%, and that will be within like this confidence interval. Okay, let's try to do the example later to explain like these two guys. Even though they are designed to answer different questions, they are similar enough to lead us to reach the same types of conclusion. This is what I just say in here. Okay. A confidence interval can lead us to the same type of conclusion as a two-side hypothesis testing. It is because the confidence intervals always consider we have to tell. When we're working on 95% confidence interval, they are talking about the 5% in the two tail here. Hypothesis testing, we do have a left tail, right tail, or two tail. Okay, so when they're saying that confidence interval will have equal to the two sides hypothesis testing. Okay, let's try to do this example together. In 2009, it was estimated that 63% of Americans support the death penalty. In 2014, a poll found that in a random sample of 943 Americans, 538 support the death penalty. Do we have evidence that support of the death penalty has changed among Americans since 2009? Significance level would be 0.025. Number one, I need you guys conduct a hypothesis testing. That would be similar to the session 8.2. Okay, state the hypothesis, state the four conditions, finding the test statistic and the p-value, and then draw the conclusion. Number two, we're going to construct a 95% confidence interval for the proportion of Americans who support the death penalty. Okay, after that, we're going to compare number one and number two. Explain how your confidence interval support the conclusion of your hypothesis testing. Okay, so try. I want you guys to work on the number one by yourself. Okay, check your word. Hypothesize. First, state the null hypothesis. This is talking about population proportion, right? So P equal to 0.63. Okay, and then claim statement. The death penalty has changed. So that will be not less than or not greater than. So this is going to be not equal to. And this is going to be the two-tailed test. Okay, right? Now, do the prepare for the conditions. First, the sample is random and independent. Second, large sample size. Plug into this formula. N will be your sample size, which is going to be 943. P naught, that will be 0.63. At least 10, right? So this is a 594. Good. And then find the number of a failure, 1 minus the P naught. You should get 349. So this is good. Number 3, large populations. So we believe the population of Americans is greater than 9,430. And then last one, independence. Okay, right? Fulfill the 4 conditions. Now, find the test statistic. This part, I just let you guys use your calculator. So the test statistic, you should find negative 3.78. P-value, that will be 0.0002. Okay, right? And then interpret and conclusion. So the test statistic, negative 3.78, somewhere like here. And that's why the p-value will be really, really small, the area of the little tail here. Okay, and 2 tails, so 1 positive and 1 negative. So we're gonna compare your p-value with your significance level. Okay, so it's really, really small p-value. We're gonna reject the null hypothesis. Okay, we reject it. Okay, we reject this guy. That means we believe that the population proportion is not equal to 0.63. Okay, so that will be our conclusion here. There is sufficient evidence to support for the death penalty has changed among Americans since 2009. Okay, one more time. We reject the null hypothesis. So we believe the alternate hypothesis is going to be true. Okay, now we're going to do the number 2. We're going to construct the confidence interval. Remember how to use your calculator? We have the X here, we have the N here. 95%, okay? So you're gonna plug in the confidence level will be 0.95. You should find the confidence interval will be 0.54 to 0.60. Okay, I'm gonna show you guys how to use the calculator. Okay, so you're gonna go to the stat, go to the test. We are working on confidence interval. Okay, one population proportion z-score confidence interval. We're gonna plug in the n 538, 943, and the confidence level 0.95. Calculate. So you do have a confidence interval. Population proportion is gonna be in between 0.54 to 0.60. Okay, right? And then remember how to draw the conclusion. We are 95% confident that the proportion of Americans who support the death penalty is between 0.54 and 0.60. Okay, now we're gonna compare with the hypothesis testing and the confidence interval. This is what we find from the confidence interval, from 54% to 60%. We're gonna go back here. So for the number 1, when we're working on the hypothesis testing, we believe alternate hypothesis is true. Population proportion is not equal to 0.63. And then when we look at the confidence interval here, the population proportion, that will be within 54 to 60%. And then 0.63 is somewhere like here. Okay, so we could say this supports the hypothesis test conclusion because 0.63 is not contained in the interval. Okay, 0.63 is somewhere like here. In other words, the population proportion has changed. Relationship between confidence levels and significance level. Significance levels and the corresponding confidence level. If you want to construct the confidence interval and compare the result with the hypothesis testing, you may need to pay attention for the confidence level and the significance level. For example, let's say we are working on the hypothesis testing. We are working on the population proportion. I just make up the data, p equal to 0.5. Alternate hypothesis, that will be p not equal to 0.5. Okay, so you know this is gonna be the two-tail test. So my pictures is gonna be looks like this, right? And since this is a two-tail, so we have the significance level. Let's say my significance level is going to be 0.05. Okay, this is talking about the area of two-tail. Okay, 0.05, the total area of the two-tail. So significance level is going to be equal to 0.05. So this is good. So if I want to construct the confidence interval based on these questions, confidence interval, I have to make it like 95% confidence level. Okay, confidence level. Because confidence interval is always talking about like two-tail as well. When they are working on the 95% confidence level, they are talking about in the middle here, there'll be 95%. So it makes sense. You could compare the result with the hypothesis testing and the confidence level. Okay, because they are working on the same thing in here. Okay, so for example, if I'm still working on the two-tail, and this time my significance level is gonna be 0.01. Okay, 0.01 is talking about the total area of this two-tail. So when I'm working on the confidence interval, I will be working on 99% confidence interval. 99%. So you can compare the result of the hypothesis testing and the confidence interval. Okay, this is the case when you have two tails. How about if I have a one tail? So this time, my hypothesis testing, p equal to 0.7. Alternate hypothesis, that will be strictly greater than. So you know this is a greater than, you will have the white tail test. Okay, white tail. So somewhere like here, my significance level, that will be equal to 0.05. Okay, 0.05 is only talking about the area of the white tail. So if I want to construct confidence interval, so think about it. What is my confidence level? Confidence level. Confidence interval is always two tail. Okay, you never heard about one tail, left tail, right tail for confidence interval. If my significance level working here is gonna be 0.05, that means this guy has to be 0.05. And since I have a two tail, so another tail that will be 0.05 as well. So 0.05 plus 0.05, that will be 0.1. Okay, so 0.1 means I'm working on 90% confidence level. Okay, in order to compare with the result in these two questions. Okay, even the left tail, right tail, you want to duplicate for the significance level in here. Okay, make it like the same thing. So one more example. Let's say this time I'm working on the left tail. My significance level is going to be 0.01. If I'm working on the confidence interval is always two tail. When this is a 0.01, same thing. This guy has to be 0.01. I need to make up one more. 0.01. Okay? So 0.01 plus 0.01, that will be 0.02. 0.02 will be working on 98% confidence level. Get the idea? On this table, they only focusing on your alternate hypothesis is going to be two sides here. Okay, that will be this picture, two tail. That's it.